Right, here a ray of light from a laser pointer is directed into a semicircular glass block as shown. There's a layer of water along the vertical flat side of the glass. Here's the layer of water, and here's the laser pointer, and here's the glass. Explain why the ray of light does not change direction when the glass block when entering the glass block. Sorry, explain why the ray of light does not change direction when entering the glass block. Your answer should refer to wavefronts, right? Okay, so if I draw right, we can draw its wavefronts like this, right? Here, these are wavefronts, right? And when normally when we are drawing waves or waveforms, we draw it like this, right? So wavefronts are these points, right? These points, right? So how can we write our answer, right? Here they have given 4 marks for this question, right? To understand what's going on, first thing you should know what the wavefronts are parallel to the boundary, right? That is the first point. So all the points, right, all the points on the wavefronts enter the glass at the same time, right? So there's no deviation, right? The wave slows down when it is moving from air to glass, but it has the whole wavefronts have the same speed, right? You should keep in your mind, right? Wave slows down, but the whole wavefronts travels the same distance in the same time because they will have the same speed. Okay, I will like over here, right? What should mention that wavefronts are parallel to the boundary, right? Wavefronts are parallel to the boundary, right? Next point is what? So all the points on the wave, or we call all of the wavefront, so all of the wavefront enter the glass at the same time, right? Next point is what? The wave slows down, right? Or wavefront slows down, right? The wave slows down as it enters the glass block, as it enters the glass block, right? But you should know the whole wave has a one speed, which we call the whole wave travels the same distance within a unit time, right? Okay, I'm gonna write that one. But right, the whole wavefront, whole wavefront travels the same distance in the same time, right? Here, right? Here I drew very small wavefronts. You may ask why. The reason is the wavefronts are just to represent the top of the wave, right? That's why I just drew, right? If you make it smaller and smaller, you can easily understand what's going on here, right? The boundary will be this place, and you can clearly see our wavefronts are parallel to that boundary. So all the points on our wavefront enters to the glass block at the same time, then the whole wave slows down, right? But the whole wavefront has the same speed, right? So the wave will, or the wavefront will travel same distance in the same time or unit time, right? What do you prefer? Right, and 1 mark for each point. You will get 4 points for this one. Right here, show that the critical angle between the glass and water is about 60. So if it is the critical angle, here we have water over here. If this is our ray, right, then what will happen if it is a critical angle? Then our ray will move like this. Right, now I'm going to use what? Snell's law. Right, Snell's law is what? N1 times sine what? Theta 1 equals n2 times sine theta 2. Right, and here we know what refractive index of glass, it is coming from the glass, it is 1.51, and the theta, right? So theta is we need to find, right? So I'm going to write 1.51 times sine theta, and here you can clearly see it is 90 degrees over here, right? It is 90 degrees, right? So we always measure it with the normal, so it is 90. Oh, where's my, right, it is 90, right? Here this is theta, right? So here it is, n2 is 1.33, the refractive index of the glass, sorry, water, I'm seriously sorry about it, water, and here it is sine 90. So you have to subject sine theta. If you subject it, you will get it is 1.33, sine 90 is 1 over 1.51, or can have sine 90 over here. So you will get the theta as, or which we call the critical angle C, or you can place C over here. It's better to place C over here, right? We use that symbol, right? It is sine C, sine C. So C is equal to 61 point, if you calculate this one, 7 degrees, right? So you have 3 marks for this one, for recognizing the Snell's law, and substitution for the 90 degrees over here, and for the final answer, right? And here they're asking us to complete the ray diagram for this one, right? Then you should know if this is our normal, then what will be this angle, right? This is our theta, right? Then if this is less than 1, 60 degrees, if this is less than 61.7 degrees, then what will happen? Our light will reflect with the same angle over here, right? So you should know what angle of reflection and angle of incident should be equal, right? Here this one also should be theta, right? Okay, that's it. And here they have given 3 marks for reflecting 1 mark, right? Here for the reflective 1 mark, and for recognizing these two same angles, 1 mark, and raise undeviate at the glass, 1 mark. So that's how they have given marks,